All right, hi guys. We're gonna walk through lesson 913 together. It's a pretty short lesson, so I'm gonna walk you through most of it with these and then give you a few minutes after this video to work on a couple of examples on the back of this. Sorry if you hear background noise. I'm sitting in the powder room right next to a fan, and this was the only place I could do this. So I'll try and be loud. Okay, so with this lesson, again, we're talking about the sign of angles based on what we did last class. Just a little refresher. We talked about the screamer. We used what we learned is called the unit circle that has a radius of 1 to figure out the height that anyone would need to climb up or down on this ride, the screamer. And we did that by figuring out that the sine of this angle, which is opposite over hypotenuse, will tell us that height. So this is a very quick recap. The sine is the height opposite divided by hypotenuse 1, which is just h. So the sine of these angles gave us the height of any chair on that ride based on how far it had rotated. So what we're going to do now is kind of extend that a little bit more. So on this circle, by the way, if you've got a straight edge, that'll be useful. You could use the edge of a binder or folder or even a different piece of paper. So on this circle, we're going to draw a triangle that could represent Renee and Antonio's position on the wheel when it came to a sudden stop. Be sure to choose a different position from any problem in 912 from last week. So I'm just going to pick for all of us a 40-degree angle rotation. So remember, straight up would be 90 degrees. So 45 is about halfway. So 40 degrees, I'm just going to eyeball right here and draw my 40-degree angle. So draw your 40-degree angle with your straight edge and keep it nice and neat. And then we know that this is 40 degrees. All right, so now we've got our angle. Now, if I wanted to know how far down or the height of this point, now all I have to do is take the sine of 40. Again, make sure your mode is always in degree. So hit the mode button right here. And you can go to degree. And once I've done that, I can just hit sine of 40. And I know that that point, remember, this is the unit circle. So if this point has a y value of 1, then the highest the y value could be is 1. This is 0.64, so slightly above halfway, which should make sense based on knowing that this is 0 to 1. So this has a height of 0.64. So with the 40-degree rotation, we've got a height of about 0.64. So if we related this back to the screamer problem, someone at that position would climb down 64 feet. Part B here is asking if any other riders had to climb the same distance up or down. If so, draw the corresponding triangle and label them completely. So if someone had to climb this exact height, the rotation they would have to take this point, think about where this exact same height would be, reflected on the other side of the y-axis. So this would have to be about right here. So this seat would also have to climb down 0.64, but this is not a 40-degree rotation all the way out to here. So if I draw this out to here, this rotation is not 40 degrees. It's 40 degrees right here. This angle is 40 degrees. So if I want to know what this, starting from 0, what that larger rotation is, we can work backwards knowing that this is at 180, straight to the left is 180. So 40 degrees before that, that means this rotation would be 140 degrees. So just subtracting 40. So we could draw or represent their climb down as well. And that's also, oops, forgot to do it over here. So we have these two seats climbing the exact same distance down at 140 degrees. So we started with 40. 140 also had the exact same height. This is asking up or down though. So did anyone have to climb the exact distance, 0.64 or 64 feet up? To figure that out, we can kind of just take the lines we drew from these triangles right here, or we can and think of it as a reflection over here. So this exact same distance, 0.64, but down here. So how can we figure out what angle that's going to be? Well, if it's 40 degrees from 180 backwards, then we can do the same thing and go 140 beyond 180, and that's going to give us our third rotation. So I just extended that or reflected it. This rotation, so if I make my triangle, the angle that it's making with the x-axis right here is still 40 degrees. So I'm kind of using the x-axis as a reference point, but from 0 degrees, so a 0 degree rotation, which would be just before you rotated, imagine getting on the ride, you've rotated 0 degrees. So 0 degrees all the way around. What is the rotation of a chair at that point? You're just going to add 40 to 180 to continue. So that's going to be 210. So 180 plus 40 is 210 degrees. That's another rotation that has the same sign. So let's see. So I should expect the exact same sign for 40 degrees and 140 degrees. So sine 40, 0.64. Sine 140, exactly the same. Now if I do sine of 210, it's going to be exactly the same, but just negative because now it's below the x-axis. So that's, whoops. That's not right. Sorry. 220, my bad. My brain, okay. Negative 0.64. Hopefully you guys caught this before I did. 180 plus 40 would definitely be 220, not 210. So we see that negative 0.64 there. Okay, and then there's one more rotation, and hopefully you all figured over here in quadrant 4, if I just take my straight edge, go straight down. So here's where it's going to be. This angle with the x-axis, again, is 40 degrees, right? But the rotation, again, if you get on the seat right here, rotate right all the way around the ride, you didn't rotate 40 degrees to get here. You actually rotated 360 minus 40. So that's going to be our rotation of 320. And so just to double check that, I can just double check, is the sine of 320? And we can see it's identical to 220. Okay, so that was 320. So all 4 of these angles had the exact same distance up or down. There's only 2 that climb the exact same distance down and 2 that climb the exact same distance up. But these 4 triangles that we just created are these 4 angles. So the angles that we made with the x-axis, not necessarily starting from 0, those are called reference angles. Reference. And the reference angle is the angle that's formed by rotating a point any amount around this unit circle and then creating a triangle in that quadrant. The reference angle is, it would be like the same angle you would have in quadrant 1. So it's the angle formed with the x-axis. Okay, so let's flip this over to the back, and we're going to kind of practice this same idea, but looking at this graph of the sine function. So we've done this twice already. You guys have taken points on your unit circle and transferred it to this sine wave. So we would take, a 40-degree angle. We would find 40 degrees on here. And then we would graph the height, so 0.64. So if this is 30 degrees or 40 degrees, this should be right about 0.64, which we can see lines up with the scaling on our y-axis. So this is taking all of the angle measures around from 0 to 360, and the height of each of these points, which we did see repeats. So I'm going to kind of trace on my left hand with the unit circle and then match that with my pencil on the right hand. So if we rotated 40 degrees, we get to here. We rotate 90 degrees, we're at the top of the circle and the top of this wave or the crest of the sine wave. Then we go back down and now we're at 180 where the height is 0. Then we go down to 270 where the height is -1 and then back up here. So this graph, this sine wave is taking this and kind of laying it out with the angle measures going left to right instead of in this circle. So we're going to use this graph to determine the height of a seat that is rotated 130 degrees. I'm going to switch to green so you guys can see this a little bit better. So we want to know the height of a seat that's rotated 130 degrees. So we could go back to this, rotate 130, which would be somewhere right there, take the sine of it and get that height. But if we were looking at the sine graph, this is just kind of another useful way to use it. We can just find 130 so you can tell, 1, 2, 3, you're at 30. So these are all scaled by tens. So 130 is right here. So if I want to know the height of the seat that has rotated 130 degrees, I'm just going to take 130, go right up to where that intersects with the sine graph. And then with your straight edge, you can kind of, to be as accurate as you can, see exactly where that's going to be hitting on the y-axis right here. So if I zoom in a little bit more. So the y-axis is scaled by tenths, so 0.5, 0.6, 0.7, almost 0.8. So it kind of looks like almost 0.8. So we'll say 0.77 or 0.76 right there. So this is 0.7 and that's 0.8. It's just under 0.8. We'll say 0.77. So it's asking the height for a seat. So that's going to be about 77 feet. If we're going back to relating this to that screamer ride, are there any other seats at that exact same height? Well, we kind of crossed that other seat in the process of lining this up with that Y value. So obviously this seat right here also is going to climb exactly 77 feet down as well. So what rotation would that be? Again, you can just trace it back. So that would be about exactly a 50-degree rotation. So the 50-degree rotation would also have to climb the same. Are there any other people who would have to climb 50 feet? What if they had to climb 50 feet up? Well, we could look for these same distances down here for the people that are already underground on the ride. So if we're thinking about what that would be, think about what our reference angle is, which would be this first angle of 50 degrees. So if I've got a 50-degree angle here, then think about, let me focus this. I don't know how to focus. Okay. So if that's 50 is my reference angle. It's the first angle, on the unit circle that's going to have that height of 77 feet. That means 50 before 180. So that's going to be 130. That's the one we started with in the problem, 130. So if I know my reference angle is 50 degrees, then I can take 50 and add it to 180 as well. So 180 plus 50, that's going to be 230. So I can go confirm that on here at 230 and go straight down. And I can see that that's going to be the negative 0.77 if I line that up with the x-axis right here. So 230. So they're climbing up, but it's the same distance. Up. And then to find out the other seats, the other rotation for the seat that's climbing 50 or 77 feet up, I would just use a straight edge to figure out another seat at that same Y value, which is right here at 310. So that would be on the unit circle, it would be right there at 310. So 310 is also climbing up. But they all have the same reference angle. So these 4 points we just did all have a reference angle of 50 degrees, meaning if you form a triangle, they would each have a 50-degree angle in the triangle. How can we use the graph to calculate which angles correspond to seats of the same height? Again, to do that, you're just forming horizontal lines. So if I'm talking about this seat, then there's another seat that's going to have that same height, and I can just use a horizontal line to see where that horizontal line also intersects with the graph of the sine function. So just here's another random example. If I want to know right here at 210, if I follow 210 to my graph, I can see someone's climbing exactly, that's at negative 0.5, so negative 50. If I want to know what other seat has that same height, I can just use this horizontal line and I can see that would be 330. Or if I want to know how many people or which seats are climbing 50 feet down, I can go up here, find out where that horizontal line is intersecting. So that's how we can use this sine graph with these horizontal lines to figure out other seats with the same height. Okay, so what you guys are going to do after the video are these couple of examples here. I'm going to do this one and you guys are going to finish this. And then you guys are going to turn this in, and when everyone's ready, you're going to move on to the next video on special right triangles. So for each of these, I want you to use this sine graph above to find the height of the seat that's rotated these different angle measures, and any other seats with the exact same, or any other angle with the exact same height. So not exact same height above or below, the exact same height. So there's only going to be 2 reference angles in each of these, and one of them is given to you. So in this example, 80 degrees is the first angle. So again, if this is 90, you should at least be able to tell me 80 degrees is in quadrant 1, pretty close to 90. So here's 80. And I want to know what is the height, and I want you to use this graph, not your calculator. So I'm going up here to look for an 80-degree rotation, which is right here. And then I'm going to use my sine graph to see what the height is at that point. Now I'm super close to 1, but I'm not quite at 1 because 90 degrees is at 1. 80 degrees is putting me at like 0.98. So you will have to eyeball it a little bit. So this is about, so 80 degrees, and the height, oops, sorry, okay. The height is 0.98, so someone would have to climb 98 feet down. What other rotation has the exact same height? Well, if I am forming an 80-degree angle here, then I want to form an 80-degree angle on this side as well. Or you can think of this reflection across the y-axis here. So it would be about right here. There's 2 ways you can think of it. You could think of it as, well, this is 10 degrees between 90 and 80. So if this is 90, I want to go 10 degrees in the other direction. That would be exactly 100 degrees. Or you could think of it as I'm 100 or 80 degrees from 0 to 80. So 80 degrees from 180, I would subtract. So 180 minus 80 is 100. So this 100 degrees is the only other rotation with the exact same height as 80 degrees, and the height is 98 feet. So I want you guys to do the same thing in problems 2 and 3 here. I want you to tell me the height at 200 degrees if a chair or a point has rotated 200 degrees. Remember, this is 180 right here. So 200 is going to be a little bit past 180, 20 degrees farther. So you're going to do that. Tell me the height of the point there, and tell me the other rotation, like I did here with 100 degrees, that has the exact same height. And you're going to do that for both of these. This shouldn't take you more than a few minutes. Once all of you are finished, I want you to turn this in. I'm going to collect it and just make sure you guys are on track with these. And then you're going to pick up the special right triangles worksheet and watch a short video on that as well. Okie dokie. See ya.